In this video, we're going to talk about some of the algebra skills that we're going to need as we go through Chapter 2. So this will be problems on that getting ready for Chapter 2 assignment. So one of the first concepts is dealing with radicals and the numerators and denominators of fractions. And whenever you have a single term in the denominator, so here I just have a single term, to rationalize, I'm going to multiply the top and the bottom by the radical in the bottom. So I'm going to multiply the top and the bottom by the radical in the bottom. Which means, in this case, I'm going to take the square root of 11xy, and I'm going to multiply that in the denominator and the numerator. And I'm having a little OCD moment this morning, and I don't like the way that looks. It looks a little rough. Okay, so let's try this again. So 33xy squared divided by the square root of 11xy. When we multiply a square root by itself, that is the operation of squaring, right? When you multiply something by itself, that means you're squaring it. And so what's going to happen is the square root will cancel out. I mean, that's kind of a bad way of saying it, but that's really what's going to happen. So in the numerator, I'm just going to leave it alone. There's nothing I can do. It's just this not radical times this radical. But in the denominator, I now just have 11xy. And it's always going to work that way. The square root of whatever times the square root of whatever equals whatever. Technically, there are absolute value bars here. But that's... Actually, I don't want to say that just yet. Alright, so now that I've got that, I've actually rationalized the denominator. Now I need to think about simplifying. And so what I notice, and this isn't something you necessarily have to write down, is I notice in the numerator that's 3 times 11 times x times y times the square root of 11xy all over 11 times x times y. Which means I'm allowed to divide these out. And so my final answer for this one would just be 3y times the square root of 11xy. And that's a fairly simple one because it's got a single term. If I go to the next one, it doesn't have a single term. Plus it also wants me to rationalize the numerator. So, whenever we have two terms in the numerator or denominator, depending on what the question's wanting us to do, we have to multiply the top and the bottom by the conjugate. So, when I say conjugate, the general form would be a binomial or two binomials in which the only difference between the two is the difference between having addition and subtraction. Now, when we multiply conjugates, something special happens. Can't spell today. Multiplying conjugates. When I multiply a plus b times a minus b, that's always going to equal the difference of two perfect squares. You know, I could go through the process of foiling this out and get a squared minus ab plus ab minus b squared. But notice what happens here. Those zero out. And so when I multiply conjugates together, I'm going to square the first term minus and square the second term. So when I look at this, this is like a minus b, so its conjugate would be the same thing but with a plus sign. So, sorry if you're wearing headphones, that sound was just annoying. So let's see here. So the conjugate would be, let's go ahead and write the problem down. So the conjugate here would be the same exact thing, but it's going to be a plus sign. All over, I got to do the same thing. So this is what I'm going to have to do on this one. Multiply the top and the bottom by the conjugate of the top. Now, what's going to happen in the numerator is pretty nice. In the numerator, I'm just going to have to square the first part and square the second part, meaning it's just going to be the square of this minus the square of this term. So the square of the first term minus the square of the second term. And the denominator is just going to be the product, so I don't even have to do much with it. It's just going to be 5 times the square root of 2x plus 5 plus the square root of 2x. Then in the numerator, I'm squaring those square roots, so I actually get 2x plus 5 minus 2x, all divided by that same mess in the bottom. Square root of 2x plus 5 minus the square root of 2x. Kind of writing sloppy here. And the numerator simplifies to just 5, which is handy because I also have a 5 in the denominator. And so when I divide out that 5 in the denominator, it's going to be a 1 on top. So I end up with 1 divided by the square root of 2x plus 5 plus the square root of 2x. And so that's how I would accomplish rationalizing the numerator in a problem like this. I think the next one I'm going to do is similar to this. I think it's just in the denominator. Nope, it's numerator again. Yeah. So on this one, it's the same strategy. Here, the conjugate of the numerator is going to be, let's see what color I want to use, is going to be the square root of 2x minus the square root of 2y. Square root of 2x minus the square root of 2y. And so at some point you may be able to take the shortcut and realize that numerator is just going to be 2x minus 2y all over y times the square root of 2x minus the square root of 2y. Again, what's happening is in the numerator, because it's conjugate multiplication, I square the first minus and I square the last term, or the second term. And there's nothing I can do to simplify that, so I'm going to call it a day. I mean, I could factor out a 2 from the top, but that's not going to help me. For some reason, this problem feels weird this morning. Sometimes when there's not much to do, it kind of feels like, you know, it's like, oh my gosh, there's more I need to do, but there's nothing I can do on this one. Now, the next couple of problems I'm going to do are going to be factoring. So I'm going to start off, this is the hardest factoring problem I've got, so I'm going to do the easiest one, which is this one. So to factor a trinomial in the form x squared plus bx plus c, you're looking for two numbers that multiply to c and add to b. And so those two numbers go here and here. So on this one, I'm looking for two numbers that multiply to negative 27 and add up to negative 6. So if I think about 27, 1 and 27, 2 doesn't work, 3 and 9, and there it is. I think those are the only factors of 27, because 4, 5, 6, 7, and 8 don't work. But 3 and 9, if I make this negative and this positive, those two numbers will multiply to negative 27, right? So 3 times negative 9 equals negative 27, and they will add to negative 6. And so my answer here is just going to be W. The order here doesn't matter. I could either write plus 3 first or minus 9 first. But that's it. But the reason why this one is so easy is because there's a 1 sitting in front of that x squared. So that 1 in front of the x squared makes me happy because I'm like, oh, that's an easy one. Yay. Now the next one I'm going to do is a little bit harder because it is not got a 1 there. This is in the form of ax squared plus bx plus c. And so here I'm looking for two numbers that multiply not to c but to a times c and add to b. Now, these are big numbers, 20 and 15. So a trick that I'm going to do is this. I'm going to go into my calculator, clear this out, yuck, 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 and I'm going to look for the factors of 20 times 15, which I think it's 300, right? But I'm going to put 20 times 15 divided by x. And when I go to my table is going to give me all the values, the nice values that multiply to 20 times 15. So if I hit second graph now and go into my table, do you see how you've got 1 times 300, 2 times 150? But I'm looking for a pair of numbers that adds up to 37. 10 and 30 make 40. Ooh, wait, 12 and 25, right there. Do you see it? Now, if you want to be really slick, you could do this. You could, on the second line, write 20 times 15 divided by x plus x. Now, if you do it this way, and guys, I know there are like calculator programs that will do stuff for you like this, but if you don't have them, then this is a good way to go. So notice now, look in this last column. It's giving me the sum of the numbers in the first two columns. And so again, if I come down here, the row that has the 12 says 12 and 25 and then 37. And so that's another way of doing it if you don't feel like doing the addition in your head. So here I just know that 12 plus 25 equals 37. Now, how am I going to use that to factor this up here? Well, you can just use trial and error. You know that you're dealing with a 12 and a 25, right? And so 12 is 3 times 4, and this is 5 times 5. Now, the reason why I broke 12 into 3 and 4 is because I was thinking, oh, this is 3 times 5, that's 15. So if I notice here, these two numbers give me 15, and these two numbers give me 20. So what I would do is I would say, okay, that means I need to have, because I need to do the 20, so 4c and 5c to get the 20c squared. And then I need to multiply the 5, one of the 5's with the 3, and the other 5 with the 4. And then everything's positive, so yay. And so notice this is going to work out. I've got 20c squared here. I've got 15 here. And then I've got 20. Ooh, I did it backwards, didn't I? Why'd y'all let me do it backwards? That doesn't work. Why doesn't that work? Oh my gosh! Probably because this isn't the way I do it. I don't know it's going to be that. So how's that going to work? You got a 3 and a 4, and a 5 and a 5. So the 4 and the 3 need to go together. That's what it is. I'm looking at it backwards. So that needs to be like that. So that I get 25 here and 12 here. So 25 and 12 is going to give me the 37. Okay, so yeah, so I need the 12 and the 25. But I need to make, there that goes. There that goes. So how's that working for me? Yeah. So I've got my, oh, I did it backwards. I've got my 20 here and my 15 here. I just did it a little bit backwards. Now, like I said, that's not the way I actually do it. This is how I do it. My technique works like this. I don't know, it's not my technique, but my technique, what I do is I push this number to the back, and I say, okay, that's going to be 300. And then from the calculator, I get that this was 12 and 25. But the problem is, this is not my actual answer. I multiplied up here by 20, so down here I'm going to have to divide by 20. It's like this cool little trick that you can play. And then I'm going to simplify. I'm going to reduce. So here that would be 3/5 if I reduce that one. And that would be, what, 5/4 if I reduce that one. And once I'm to here, I'm just going to bring my denominators up in front of my variable. So 5c plus 3, and then 4c plus 5. You know, there's also the AC method. There's some other variations of the methods. The main thing is when you have big numbers, how can you figure out what the values are that you can use to do that, to do the, what was I going to say? To do the factoring. Now I'm going to go back to the other one, the hard one. It's not really that hard. It's just that there's a D and an S here. So when we have this structure, I know it's going to be a D here and an S here, and a D here and an S here. And so I'm looking for two numbers that multiply to 30 times negative 35, which is gross big number, and then add up to negative 17. So what I'm going to do is I'm going to go to my calculator, and I'm going to change this to 30, I already forgot it, 30 and negative 35. 30 times, negative, let me insert there, 35. And then down here, same thing. I'm going to do 30 times. Alright. So now that I've got my little equations in here that I can use to help me figure out my numbers. And by the way, just so we know, it's going to drive me crazy if I don't know. 30 times negative 35. I should probably do that in my head. But negative 1,050. I'll write that here. But going to my table, I'm looking for a negative 17 over here in this last column. So notice I need to go down to make those numbers get smaller. So as I go down, looking for negative 17 over here. Oh, there it is. All right. Now, just to show you guys the method of grouping, what I would now do is I would break this into, let's say, 30 d squared minus like 42 ds. Move this over here. I was so happy I remembered to put my phone on silent, but it's still making noise. Now, I could have switched these, but I thought the 25 might go with the 35 better. Who knows? It should work either way. Now that I've got this rewritten using my special numbers that I got from my calculator, I'm going to factor by grouping. So if I look at the first group here, 6 will go into both of those, and they both have a D. So if I factor out the 6D, I would be left here with 5D minus 7S. I'm going to do the same thing over here. Both of these, the biggest number that goes into those two would be a 5, and they both have an S. And so this would end up being 5D, when I factor it out, minus 7S. And so lo and behold, I have a 6D and a 5S that I can group together and have it share 5D minus 7S. So they both have this in common. And by they, I mean this right here. So I've got this, I factored that out, and I was left with 5D minus 7S. So that's kind of a challenging factoring one. But to me, if you can factor something like this, then you're good to go. All right, I've just got one more. The last concept that I want to talk about is just understanding how function notation relates to points on a graph. So, if you remember, f of x equals y. That is what f of x means. So, if you're asked to find f of a value, then you're asked to find its y value, its output. And so, really, what's going on here, when you're given something like f of negative 2, basically it's telling you that the x-coordinate is negative 2, and f of negative 2 equals the y-coordinate. So another thing I think that's important to note here is that I could have also written this as x comma f of x. So again, it's all just like an idea of notation and substitution. So if I'm looking to find f of negative 2, well, f of negative 2, I'm going to go to where x is negative 2, and I'm going to look for its y value. So at this point right here, the point x, negative 2, negative 3. So this would be x, and this would be f of x. Or in this case, f of negative 2. So f of negative 2 equals negative 3. That's all you're doing. But it's important to understand that. So for f of negative 1, I go to where x is negative 1, and I look at that point, and that is the point negative 1, positive 3. So that means f of negative 1 is the y value when x is negative 1. So f of negative 1 is, the y value when x is negative 1. So f of negative 1 is the y value when x is negative 1. F of 0 is the y value when x is 0. So on my graph, when x is 0, the y value is 2. So f of 0 is 2. So it's kind of funny, all those hard ones, and then boom, that's all. And so this should be able to definitely assist you on the getting ready for chapter 2.